In this video, we're going to revise how to find missing sides using SOHCAHTOA. It's important to remember that this method only works with right-angled triangles and that we use the sign theta to show the angle. Here's the information for our right-angled triangle, and we're trying to find the missing side x. First step is to label the sides of the triangle, the hypotenuse, opposite and adjacent. To revise how to do this, check out the previous video on labelling the sides in a right-angled triangle. Next, we cross out the side that's not being used, in this case it's the adjacent side, and we circle the two sides that are involved, in this case the hypotenuse and the opposite. Again, to revise how to do this, check out the previous video. Next, we identify in the word SOHCAHTOA which part uses the opposite and the hypotenuse, and that part is our sine function ratio, which we write like this. Again, for help how to do that, check out the previous video on writing trig ratios using SOHCAHTOA. Our next step is to sub in the values we know for theta, opposite and hypotenuse, and the final step is to solve this equation so we find out what x is. To do that, we use the normal rules for solving equations. So we do the same thing to both sides to get the unknown on its own. First thing is we want to get rid of this divide by 10. To undo that, we times both sides by 10. That gives us 10 times sine 50 degrees is x. And now that x is on its own, we can just put the 10 sine 50 degrees into our calculators. We'll get a long number like this, which we can round to 2 decimal places like this, 7.66 centimetres correct to 2 decimal places. Here's one for you to practice. See if you can find the missing side x. Pause the video now and then check your answer. In 3, 2, 1. First label the sides. Then circle the sides that are involved, identify which part of SOHCAHTOA we need, and write the trig function, substitute in the values that we know, and solve the equation to find out what x is. Here's another example. This time we're going to have one extra step, but all the same rules apply. So we've got a right-angled triangle, and we've got this extra information. We're trying to find the missing side x. First step is to label the sides. Next, we cross out the side that's not involved. That's going to be our hypotenuse. We circle the sides that are involved, opposite and adjacent. We find which part of SOHCAHTOA involves the O and the A. So we're going to need our tangent rule. We write out the ratio for tangent, substitute in the values we know, and now we need to solve for x. This time there's going to be an extra step to get x on its own. That's because at the moment we're dividing by x, it's the denominator. Last time x was on the top. But all the same rules for solving equations still apply. We do the same to both sides to get the unknown on its own. This time we start off by multiplying both sides by x. That gives us x tan 62 equals 6. We need another step to get x on its own. We need to divide both sides by tan 62. This tells us what x is. It's 6 over tan 62. That's what we can put in our calculator. It gives us this value, which we can round to 2 decimal places. And we found the missing side. And here's one for you to practice. Pause the video now, have a go, and check back your answers. The solution is coming in 3, 2, 1. So first step is to label the sides and identify which sides are involved. It's the opposite and the hypotenuse, so we're going to use the sine trig ratio. Next, we substitute in the values that we know and solve for x. And our answer is 11.41 centimetres correct to 2 decimal places. How did you do? You can replay and reuse this video as many times as you need, and when you're confident with this method, you can check out the next video on finding missing angles using SOHCAHTOA.